Hello. So we are going to start this week with reviewing how to assign oxidation numbers and how to decide what's been oxidized and what's reduced. Because you guys didn't do that well with it last week, which means I guess I didn't teach it very well. So let me try again. This time I'm going to give you more space and give you like a better example. So here's our problem, and we're going to write oxidation numbers up here, and then down here we're going to determine who was oxidized and who was reduced. And this is your actual homework, so this should be a good free answer for you. All right, so here we go. So we're just going to start on the left, CS, what's its charge? So I start looking it up on the periodic table, top left corner, but then I'm like, oh wait, it's alone, so it's automatically a 0. So I'll just write a 0 right there. And then I'm just going to space over to the Mg. All right, Mg, what are you? You are in a compound. So if I look at Mg top right corner, obviously this is really small, but you can zoom in on yours. But it does say +2. So I go, okay, Mg, you're +2. +2. All right, so what must Cl be? So you might be like, oh, it needs to be -2 so that they add up to 0. But this little 2 right here says that there are 2 Cl's. So I would need each of those 2 Cl's to be a -1, which if you look at Cl top right corner, that's its first negative choice, or its only negative choice. So right now this adds up to 0 because it's just 0. This one right here, we have a +2, so then this must be -1 because there's 2 of them. And if you want, you could do the math down here. Right? This is +2, so this adds up to -2. So this is the math down here. These are the actual oxidation numbers that I'll actually answer. All right, so then I'll just space, I'll space over to the next one. CS, if I look in the top left corner, right corner, it says +1. And so Cl must really be -1, and it is if you look it up. And then Mg, I'm like, oh, I remember Mg. It was my +2. But wait, it's alone, so it is a 0. Okay, so now that I have written those numbers, I can come down here and decide who was oxidized and who was reduced. You can see the answer bar is only on the left because only the stuff on the left can be oxidized or reduced. The stuff over here is like the results of that. So we're going to pick always something on the left. So I'm just going to look at each thing and look at what happened to its charge and decide what happened to it. So I'll just start with CS. CS was, let me use a different color. CS was 0, and now it became +1. So it looks like it went up. So we said ox up. So I'm like, oh, okay, CS, you got oxidized. Oxidized. Okay, so I just write below, okay, that's the thing that got oxidized. Or you can write oxidation, whatever, or ox. And then I'm just going to space bar over. All right, let me check on Mg, or I could check on Cl and go, okay, Cl was -1. Now it's -1. Nothing happened to it, and that's fine. Let me do a different color, yellow. Mg, what happened to you? Mg was a +2, and then it became a 0, so its charge went down. So it got, the memory trick is reduced down. A lot of memory tricks in this unit. So I'm like, okay, Mg, you got reduced. So I'm going to write reduced right below Mg. All right, so we are picking oxidation numbers up here that make, remember, things that are alone add up to 0. Let me do a different color. So things that are alone are always 0. And then compounds, you have to look up their oxidation number and then assign them and do the math so that their oxidation numbers, when you include like this 2, add up to 0. Remember, I found those numbers in the top right corner of each little box. So like right there. So if you zoom in, you'll be able to see that. What else do you have to know? So once I assign all these oxidation numbers, then I can look, okay, what happened to each? It went from being 0 to +1, so it went up. So it was oxidized up. Mg went from +2 down to 0, so it got reduced down. All right, so assign all the oxidation numbers up top, decide who got oxidized and who got reduced down the bottom. So that example is already done for you. You can fill that in your answers. And then there's another example that I would like you to do yourself. So again, assign the oxidation numbers up here. Remember, the loners are zeros. And then down here, write who got oxidized and who got reduced. All right, good luck.